Hello everyone, I'm Jae Kyoung Kim from the Department of Mathematical Science at KAIST and Biomedical Mathematics Group at IBS. Today, I'm going to talk about how the combination of mathematics and AI can be used to make your life healthier and happier.
Oh, it sounds already difficult.
Yeah, but it's okay. So I will do my best to explain as easy as possible. For this, you have to learn math today. So let's begin. Have you heard about this?
Oh, I have no idea.
Oh no, you
High school.
did it. Yeah.
School. Yeah.
Yes.
I must have been asleep during
Yes.
that class.
Yeah, it's a function y equals f of x. What that means is if we plug in something into the x, then output y came out. We call this is function. Let's begin with a simple quiz to understand what is a function. Okay. There's a question mark. Can you guess what this should be?
Five?
Yes, 5, correct? Why you imagine this 5?
The function is adding 1 to x.
Yes. So you found some pattern, right? To answer this question in your brain, you already recognize this pattern, y equal x plus 1. Can you guess what is this question?
No, I cannot.
Compared to the previous problem, the number of the x is increasing to the 4. That means you have to consider more data, right? So that it becomes way more difficult problem. Actually, the answer for this is that.
It looks so complicated.
Yeah, I know, yeah.
Yes.
So to answer this question mark, you have to come up with that function from this pattern. Is it easy or difficult?
Very difficult.
Yeah.
Time.
Yeah.
It's a lot of time.
Actually, even for mathematician, this is nearly impossible problem. Just looking at this number and come up with this function is very, very difficult. However, nowadays, you heard about AI or machine learning, right? So if we use this simple machine learning code,
Simple.
because it's just 10 lines of code. If we plug in this number or data set to this simple code, you will see the answer there. It's not exactly same with the original function. It's pretty close, right? So why this is important for us is to make a prediction, we need to find the pattern, right? That is equivalent to finding the function. But finding the function is not easy, right? But nowadays, AI does it for you automatically. Thinking about your life, making a prediction is important or not? Very useful, right?
Yes.
Yeah? So AI can do it for you. Sleep. Yes. According to the survey, around 60% of the adults have a certain type of sleep disorder, insomnia or sleep apnea, etc.
I definitely have
Okay,
some sort
yes,
of...
yes,
yeah,
yes,
you
yes.
too as well?
Yeah. So the survey is correct. But although 60% has sleep disorder, but only 6% of population has been to the hospital to be diagnosed for the sleep disorder. But why this is a big issue is, recently there was one study from the Europe. What they did is, the OSA is a sleep apnea. They tracking the life of the sleep apnea patients. What this blue curve means is, OSA patient, but who didn't get the treatment, and then they follow up 30 years, and then they check how many people are survived. Can you see how many people are survived after 30 years?
Oh, wow.
0. All die. But those who got the treatment is a green curve. How many survived?
That's
80%.
such a big gap as well.
Yeah, big gap. It's between 80% versus 0%. Why people don't go to the hospital to get the diagnosis for the sleep? Why? The reason is it's not easy. Then first you have to do some survey. And then they perform the polysomnography, PSG. They attach a lot of the sensor in your body. You have to sleep there 12 hours for the diagnosis. It's very time consuming and then furthermore expensive. So it's not about the treatment. Just to know whether you have a sleep disorder or not, you have to do this. That's why this is a bottleneck. That's why only small population can get this kind of diagnosis. To overcome this issue, we have to remove this PSG part, right? Then it would be easier. What we did is We got about 5,000 patient data who did this PSG test. And then we divide the data into the two sets. So we got the survey data regarding the answer to the 40 different questions. So that 40 different questions and then 5,000 patients. So it's a huge data set. And then I saved this data called X. This is very important. I call this is X. And then right side data is another data called Y. What that is result of the PSG test. Then why I dissect the data set into the X and Y?
To find the function.
Oh my gosh.
You're clever.
Adam, please do your best.
I'm trying.
Yes, yes. So exactly, we want to make a function y equal f of x. X is survey result. Is it easy to get or difficult to get? Very easy. So it's a cheap data. But y is result of 12 hours of this PSG test. Y is difficult or expensive data, right?
Yeah.
So, but if we can make the function y equal f of x, what that means? Plug in the cheap data, and then output will be expensive data. Okay? But the problem is now how many x do we have? x1 to the x40. Way more complex than previous example, right? So the human cannot do this. But who can make this function?
AI.
Yeah.
Exactly. Now AI can make this function automatically. So that we use the AI algorithm to find this function. Two things were very surprising for us. Number one, we expect it should be the function of from x1 to the x40. We use this AI algorithm, and then the function turns out x1 to the x9 rather than x1 to the x40. What that means is there is only 9 variable, x variable. That means we just need, rather than 40 questions, just 9 questions. And then second is about the accuracy. Of course, we're just using the survey data to predict the 12 hours analysis results. So it cannot be perfect function, right? So what would be okay for you? How much accuracy you'll be happy?
100.
90%?
Yeah, 100.
100%. Yeah, 100% is impossible. But what we got was around 90 to 95% accuracy
Oh, wow.
for 3 different type of sleep disorders. It was quite amazing for us. So we make the sleep-math.com. You can use it now. I already answered to the 4 question. And then another 5 question. It just take 1 minute rather than 12 hours. Then game is over.
Wow.
Then Y's came out like this. So what this tells us is chance of OSA risk is 55%. When I got PSG test, what I got was you are in the borderline between normal and OSA. That's my diagnosis. You can see that it's pretty accurate.
Yeah.
So after we launched this website, so far about 10,000 Korean people has been used per month. So that as a result, a lot of people go to the hospital to get that PSG test when they got the high risk. So what that means is now with this function or website or sleep algorithm, a lot of people who thought that I don't have any sleep disorder, they can recognize they may have certain sleep disorder, and then they can go to the hospital to get the treatment, right? So basically, we can convert the people from this blue curve to the green curve. That means survival rate 0% to the 80% with this function. So what is a function? Y equal f of x, but x should be what? Cheap data or is data, and then y should be expensive data. And this function f will be identified using the AI algorithm. Then it becomes very useful, right? Because cheap one is converted to the expensive one. So one example of this thing is actually automatic driving system. What the Tesla's automatic driving system does is X is image or video outside of the car. That's X. That's easy to get, right? And then Y is driving or acceleration or deceleration. That's Y. And what is function F? it's made by AI. So all the nowadays big tech company has their own this kind of function. And the characteristic of that function is cheap one is converted to the expensive one or more useful information. Clear?
Clear.
Yes, good. So sometimes we can use AI to identify the function, but sometimes we fail. Let me show you why sometimes we fail. This is neural network, one of the most famous AI algorithm which mimicking our neuron structure. So you may heard about the deep learning.
Oh, yes.
Yes, that's based on this kind of neural network. So how this neural network working is, dots are data, and then let me ask this neural network to identify the function which mimicking this data. You can see that it's beautifully fit to the data well, but the problem is outside. So this side is no data set, right? In that case, what happened? It's completely different from the answer, right? So that's the problem of the AI. For the inside of data set, it works very well, but outside of data set, it doesn't work. That's why we need a lot of the data.
So, Professor, you mentioned that outside of a data range, the AI tends to break down. Could you give me an example of what that might look like?
Now let's think about automatic driving system. So let's imagine that we only feeding the data from the smooth highway driving. Then let's make the AI driving system goes to the rural road, where road is not in a good condition, bumping. I believe that then this AI driving system may fail. So that's something you can imagine. So that's why to make a good automatic driving system, we let the car go to a lot of places so that they can experience many things. Recently, researchers find a way to overcome this issue. Basically, if we teach AI calculus or derivative or integral, then, for instance, this is one of the physics law. If we teach this physics law, you can see that even outside of data set,
Oh, it's more accurate.
yeah, much more accurate, right? Because calculus is a way to describe the world, like a Newton's law.
Right.
Then AI becomes smarter. This is the power of the calculus. Yes.
Professor, why the AI developers didn't teach the calculus from the beginning?
Oh, I see. Very good question. AI researcher was focusing on to find the pattern from the data. Basically, the function y equal f of x. For instance, you heard about the AlphaGo, right?
Oh, yeah.
Yes. Even we didn't teach the calculus, AI did a great job. But there is also the other cases where AI failed. They realized that, wow, we should teach velocity or acceleration or this kind of physics law, then we can overcome the problem. That's why nowadays this physics-informed AI become very, very popular, so that AI research now turns back to the mathematics. Cool?
I see, yeah.
Then, so far I keep talking about this calculus. Do you remember?
To be honest, I just have no idea what that is.
Same, yeah.
Let me do my best so that you can understand what's the calculus in 30 seconds. Here is a car. In a math, when car is moving, we always call the moving distance is x. You remember all math problem begin with that kind of sentences, right? Car is moving, and let's call the moving distance is x, right? So that, as you can see, as time goes, x is going up. Does it make sense? But right side, you can see that there's attractive character here, dx over dt. That's the x's derivative. dx means how much x is changes. dt is how much time is changes. How much distance changes, how much time is changed. What is the ratio? We call that velocity or speed. So if car moving like 100 kilometer for 2 hours, 100 kilometer divided by 2 is 50 kilometer per hour. So velocity is basically derivative. of x. So derivative is nothing but just velocity, which represent how quickly something changes. So if pitcher throw the ball is moving, right? How quickly this ball is moving, we call velocity, right? That's the derivative. Then let's solve the problem.
Oh gosh, now it's the real thing.
Okay, so in summary, the derivative is nothing but the velocity, how quickly something changes. And then, for instance, Aaron, your bank deposit increasing or decreasing?
Decreasing.
Oh, sorry. Anyway, how quickly your deposit changes, we call it's a deposit's velocity. So if it's a plus, that means increasing.
I
Minus,
wish it was plus.
Yes, that's the point. So velocity is nothing but how quickly something changes. Then let's solve the problem together. dx over dt equal 10. That means x's derivative equal 10. That means velocity is 10. So your car, you drive the car with the velocity 10. So then what that means, if the car is moving by like a time 3, how long car is moving then?
30.
30, yes, correct. 10 times 3, 30, perfect. What about time after time equal 10? 10 times 10, so that 100. Make sense? What if after time equal t? 10 times?
Yeah.
Yes.
I'm getting lost.
Yeah, now I don't know.
Okay. So let me try one more time. After t equal 10,
Okay.
then 10 times 10, so that 100, right? After just the time t, I don't know how much is. We call this 10 times t. That's how much the car is
Oh.
moving, isn't it? Make sense?
Yes, yes, yes.
So that
Yes.
x equal 10 times of t.
Yeah.
That's we call integral. Opposite of the derivative. So what integral means is when the velocity is given, predicting what will be the x, where will be the car is, we call integral. So velocity information is converted to the position information we call integral. And then if I draw the ball from the velocity information, predicting where the ball's location is, we call integral.
I see.
So now we are done about the calculus. Now let's go to the navigation. In the typical navigation, there are usually 3 different numbers. One is the velocity, car speed, and then distance, how much left, and then arrival time. So among these 3 numbers, which number usually you have most interest in? Think about it. Let's survey. Who has most interest in distance? One person. Velocity. Arrival time. Yes. Okay, 1, 2, 3. Yeah, but this is typical. So typically people has interest in more arrival time. For the distance, can we measure? Yeah, bring the map, we can measure it, right? What about the velocity? Can we measure?
Not by ourselves.
Is it possible to measure?
Oh, yes.
Yeah, it is possible.
Yes, because that's why the police speed gun,
Yeah.
isn't it? So a distance velocity can be measurable. But what about the arrival time? Can we measure?
Yes.
How can we measure?
Based on how fast you're going in the distance.
Ooh.
Yeah.
Wow.
See, I'm
Oh,
pretty smart.
yeah.
Thank you, thank you.
See, yeah, great point. So basically, speed and remaining distance can be easily measured. It's easy information, ship data. But arrival time, majority of you have interest in, we cannot measure it because it's about the future.
Right.
We have to make a prediction. It's expensive data. Yeah,
Is the arrival time y in the equation?
exactly.
I see.
That's
okay.
the point. So distance, velocity is x, cheap. But arrival time, y. But how navigation predicts arrival time? Actually, Aaron make a great point. Actually, that's what exactly did previously. When velocity is given, you predict the future position of the car, right? Using the integral. If we make a decision where to go, then navigation will collect all the velocity information across the road from other car, right? And then doing the integral, we can predict the future car position, and then we can predict when it reaches to the arrival position, and then by calculating, we can predict the arrival time. So that your navigation using the calculus to convert the X information to the Y information.
Now I'm gonna see the navigator like go in a different level.
Different way. So you learn the calculus when you're young, but I think you didn't know why we learn, right? So why calculus is necessary for our life is it can predict the future state, which you have interest in, from the easily measurable velocity information. That's why we learn the calculus. Cheap data, velocity, to the expensive data, future. Don't you have interest in your future deposit?
Oh, of course.
Yes.
At this point, no.
Yeah.
I see where it's going. Yeah.
Yeah, exactly. So that's how the calculus is used. Make sense? Now we need to combine everything we learned. Calculus and function. Do you remember the function, right? And then we will merge it with the calculus. So what we did is we tracked the depression and bipolar disorder patients. The goal of this project was something like this. I don't know, you have any friends who has a depression or bipolar disorder. So if you look at them, usually they are very normal. But suddenly, unpredictably, depression or mania comes and it maintains a couple weeks or sometimes a couple months. That's the issue. So usually they are totally fine. But suddenly it comes. So that makes the life is tougher. So what we want to do is, can we predict when the depression or maniac episodes come in advance?
No, it's unpredictable, isn't it?
Yes, let's see. So what we did is we provide a smartwatch to the patient, and then we tracking their sleep-wake pattern like this every day. It's easy data, right? And then we plug in their sleep-wake data to our mathematical model describing the sleep pressure and circadian rhythm. So that means for this patient, now we can draw their black line and yellow line, right? And then plug in this information to the AI algorithm so that graph is now X. And then plug into the AI algorithm, then what's the Y is when they will become depressed or when they become maniac. So here X is cheap or expensive. Sleep data, plug into the equation to grab cheap, right? What is Y? Predicting the
depression
episode.
and manic.
That's expensive. If we can make that kind of AI algorithm, that's useful or not?
Very useful.
Very
Oh,
useful.
yeah.
So it
So
can
we did
become
it.
predictable.
Here is the result. This is accuracy. For the depression episode, we can predict in advance with 80% accuracy. And then maniac, 98% accuracy. It's extremely accurate. We just use sleep-wake data, no information at all. Just sleep-wake data, we can predict when this patient will suffer from depression or maniac in advance. So what does this mean? This is depression probability calculated by our AI algorithm. You can see that it keeps changing, right? Depending on their sleep pattern. You can see that there is a zone probability is extremely high, right? This is when indeed this patient suffer from the depression episode and go to the hospital. So we can do this every day. So what that means is when this risk is increasing, we can give a warning signal. And then we can also tell that you should sleep in this way to reduce risk. So that means before going to the depression episode, hopefully by adjusting the sleep-wake pattern, we can prevent the depression episode. That's what we are trying to do in the future. So this is summary. Mathematics, unexpectedly essential for our lives. And then it can be, indeed, can be used to make your life healthier and happier.
After listening to your lecture today, I'm actually thinking maybe I should give math another try.
Wow.
Yeah.
But where would you recommend starting?
Rather than straightly diving into the textbook, it will be very challenging. So I strongly recommend watching some YouTube lecture or reading a popular science book, which talk about how math can be connected with your real life or daily life. Okay, so math is no longer something that only lives on chalkboard, but it can be useful to understand ourselves better and design better tomorrow. Thanks for joining me today.
Thank you.
Hello, I'm Hanbyul Ju, a professor at Seoul National University in the Department of Computer Science and Engineering. So which one is generated by AI?
First one.
I think the second one is.
In fact,
Nowhere.
My God.
So I feel like it's a living thing these days.
let's talk about the future of AI. AI needs to learn about human behaviors, emotions as well. How AI turns your imagination into something real.